Hello and welcome. In this video I'm going to show you how we can find tangent line to a curve using definition of derivative. Let us start with this question. Find the equation of tangent line to the curve y equals x to the 2 plus 3x at the point 1, 4. Let me remind you, equation of a line in general. If you remember, we can write equation of a line using this formula. And if you remember, this is the point slope form, because in this formula we need the slope. M is the slope of the tangent line, and x0 and y0 is the point that we need for writing equation of a line in general. Here in this question we have the point, so we want equation of a line that passes through this point. So basically we have x0 and y sub 0. It's 1 and 4. The only thing that we need for equation of tangent line is the slope. How we can find the slope of tangent line? For finding a slope of tangent line, we can use this formula or this formula. F prime of a, which is a notation for derivative of a function. F prime shows derivative of the function f, and the a shows the point that we are finding derivative of that point. This is just a notation. And basically f prime of a shows the slope of the tangent line. So for finding the slope of the tangent line m, you can use this formula or this formula. And of course, the answer of these limits is the same. And it's completely up to you which formula to use for finding the slope of tangent line. Here in this video, I'm going to use both of these formulas for each question, so you can understand both of these formulas, and then you can decide which formula you prefer to use for yourself. So, the process of finding equation of tangent line basically is finding these limits, because this is the most important part. We have the point, we have x0 and y0. Only we have to find the slope of tangent line. And how we can find the slope of tangent line? By using this formula or the other one. So let us start to find m, or a slope of tangent line. Here we want the equation of tangent line at which point? At the point of 1, 4. So basically this 1 is a for our formula, because this shows the x coordinate of the point. And in this formula, a is the x coordinate of the point that we want to find equation of tangent line at that point. So for finding the slope of tangent line, basically I have to find f prime of 1. Let's start with this formula. Based on that formula, we have to find limit of f of x minus f of 1, because attention, we want to find tangent line at this given point, and at this point the x coordinate, which shows a, is 1. So in this formula we have to replace every a with 1. So the formula becomes f of x minus f of 1 over x minus 1 as x approaches 1. Let's start to find this limit. What is f of x in this question? F of x is x to the 2 plus 3x. So we have to find limit of f of x again. F of x is this expression. So we are going to replace f of x with this expression minus f of 1. What is f of 1? Simply, you have to plug in 1 for x here and here to find f of 1. Based on this formula, f of 1 from here, f of 1 would be 1 to the 2 plus 3 times 1. 1 to the 2 is 1 plus 3 equals 4. So f of 1, all of this is only 4. All over x minus 1 as x approaches 1. Now here we have a limit. It's in the fraction form. And basically for finding limits, the first thing we usually try to find the limit is substitution, direct substitution. But if you substitute 1 for x in numerator and denominator, you can see that the numerator would be 0 and denominator would be 0. If you plug in 1 in the denominator, you have 1 minus 1 in the denominator, which is 0. And also if you plug in 1 here, it would be 1 to the 2, which is 1 plus 3 times 1 is 3. 3 plus 1 is 4. 4 minus 4 is 0. So direct substitution doesn't work for finding this limit. When direct substitution doesn't work, you have to try to simplify the expression in front of the limit. And it should be clear for you that you can probably factor this quadratic. Simply to put 2 brackets, x in each bracket. Try to guess two numbers that their product is negative 4. When we times those numbers that we look for is, we times them, it's negative 4, and the sum of them is 3. Can you guess those numbers? One of them is 4 and the other one is negative 1. So plus 4 minus 1 all over x minus 1 as x approaches 1. Now if you cancel x minus 1 from numerator with x minus 1 from denominator, then we have limit of x plus 4 as x approaches 1. Now again, if we try substitution, if we plug in 1 here, we can find the limit, and the limit would be 5. So the slope of tangent line is 5 for this function. This shows the slope of tangent line. Now that we have the slope of tangent line and we have the coordinate of the point, which is 1, 4, simply we can write the equation of tangent line. Let me write down the equation of tangent line, and then after that I am going to show you how we can find a slope with the other formula that is here. But first let me write down the equation of tangent line. The point that we had was 1, 4. The slope of the tangent line is 5, so the equation of the tangent line would be y minus 4 equals 5 times x minus 1. And of course you can simplify this. For example, you can multiply 5 in the bracket, move the negative 4 from the left to the other side. Those things are optional. Basically, this is the equation of tangent line. Let me show you how you can do that. Y minus 4 equals 5x minus 5. And if we move negative 4 to the other side, this would be 5x minus 5 plus 4, which is minus 1. And this is the equation of the tangent line to this function at this given point. Before I show you how you can find the slope with the other formula, let me tell you something about this given point. At this given point, the x coordinate is given 1. And sometimes maybe they don't give you the y value corresponding to this x value. And actually you don't need to have this 4 here. Simply, if you plug in 1 in this equation here, you can find the y value by yourself. So it's not necessary that they give you the y value. For example, here, if you plug in 1 for x in this equation, if you plug in 1 here, you can see that it is 1 to the 2 plus 3 times 1, and it equals 4, which is this value. So the only thing that we need is the x coordinate of the point, because we need it to find the slope of the tangent line at that number. We need x coordinate only. Now let me show you how we can find the slope of tangent line with this formula. First, let me rewrite that formula here. F prime of a equals limit of f of a plus h minus f of a all over h as h approaches 0. In this case, we want to find f prime of 1. We want to find a slope of tangent line. Attention, f prime is derivative. And one of the interpretations for derivative of a function is the slope of tangent line. So you can think f prime as a slope of tangent line. We want the slope of tangent line at the point or at the number 1. So this is how we can consider this notation. F prime of 1 based on this formula would be limit of f of 1 plus h minus f of 1 all over h as h approaches 0. Now remember, what was the function? The given function was x to the 2 plus 3x. So let's rewrite this formula based on that function. First, let's see what is f of 1 plus h if f of x equals this. When f of x equals x to the 2 plus 3x, if you want to find f of other things, any other thing, simply you have to replace every x with that thing. For example, if I ask you what is f of z, you have to say z to the 2 plus 3z. If I ask you what is f of a, you have to say a to the 2 plus 3a. Now here we want to find f of 1 plus h. So for finding f of 1 plus h, simply you have to replace every x here with 1 plus h. So what is f of 1 plus h? It would be 1 plus h to the 2 plus 3 times 1 plus h, and that's it. This is f of 1 plus h. Now we have to find f of 1. How we can find f of 1? Simply replace every x again in this equation with 1. So f of 1 would be, let me put a bracket here, because minus is for f of 1. So minus f of 1. What is again f of 1? 1 to the 2 plus 3 times 1 all over h. Maybe here for you it seems that the first method, the first formula, this formula is easier to use. It depends to the question and the equation and the function. Not necessarily always that formula is better. But at least maybe in this question it seems that method was easier for finding a slope of tangent line. But let's try to see what is this limit. Again, similar to all limits, we have to simplify. Immediately, if you want to plug in and direct substitution, doesn't work. You are going to get 0 over 0. First, you have to try to simplify numerator. Probably you know how to find 1 plus h to the 2. You have to expand this. You have to open this. If you know the identity for 1 plus h to the 2, it would be great. But if you don't know the identity for finding that, you can simply multiply 1 plus h by itself. If you multiply 1 in 1, it would be 1. 1 times h is h. H times 1 is again h. And h times h is h to the 2. So it is 1 plus 2h. Attention, these two are like terms. They are similar terms. H plus h is 2h. And finally h to the 2. But if you know the identity, you don't need to do this calculation. And directly you can find this. So what is 1 plus h to the 2? It is 1 plus 2h plus h to the 2. Now, let's multiply 3 to the bracket. 3 times 1 is 3. 3 times h is 3h. Minus 1 to the 2 is 1. 1 plus 3 times 1 is 4. So we have minus 4. The expression inside the bracket is 4. So basically we have minus 4 all over h. 1 plus 3 is 4. Minus 4, it cancels. It equals 0. So let's see what remains after this. We have limit 2h plus 3h is 5h. And we have h to the 2 all over h as h approaches 0. Now if we look at the numerator, simply you can see that we can pull out h. If I factor h from this term and this term, I have h times 5 plus h all over h as h approaches 0. If we cancel h with h, if we cancel the h from the numerator with h from the denominator, we get limit of 5 plus h as h approaches 0. And if we substitute 0 for h, the limit equals 5. So 5 is the slope of tangent line. And if you remember, here we got same number for the slope of tangent line. So it doesn't matter which formula to use for finding a slope of tangent line. But sometimes maybe one of these formulas is easier for finding a slope of tangent line. Now let's try another example. Here we want to find equation of tangent line to the curve y equals radical 2x plus 1 at the point x equal 4. First of all, note that here the only thing that from the point we have is the x coordinate of the point. And of course, directly if you substitute 4 inside the equation, you can find the y coordinate of the point, because you need finally the y coordinate of the point to write the equation of tangent line. Remember the equation of tangent line? The equation of the tangent line is y minus y sub 0 equals the slope of the tangent line times x minus x sub 0. We need the x coordinate, which here we have, and also we need the y coordinate of the point of the tangency. But only we have the x coordinate. It's given here. If you plug in 4 for x in the function, you can find the y coordinate corresponding to this x value. So you can simply find the y sub 0. But the most important part is to find the slope of the tangent line. That's the tricky part. So first, let's do the easy part. Let's plug in 4 in the equation to find the y value. When x equals 4, the y value would be radical 2 times 4 plus 1. 8 plus 1 is 9, radical 9 or square root of 9 is 3. So from this, the point is 4, 3. Now we have to find the slope of the tangent line. For finding the slope of the tangent line, First, I am going to use this formula. F prime of a equals limit of f of x minus f of a over x minus a as x approaches a. This formula is for the point A, the point that the x coordinate of the point is a. But here the x coordinate of the given point is 4. So in this formula I have to replace a with 4. So we want to find f prime of 4, which would be limit of f of x minus f of 4 over x minus 4 as x approaches 4. And remember, the function was this, radical to x plus 1. So f prime of 4 would be limit of f of x is the function, radical to x plus 1 minus f of 4. Plug in 4 here and find the value of the function when x is 4. And actually we did this here. When we substituted 4, we got 3. So minus 3 all over x minus 4. Now we have to try to find this limit. Again, direct substitution doesn't work. Do not try to directly substitute 4 for x. If you do so, you are going to get 0 over 0, which is an indeterminate form. So direct substitution never works at the beginning. First, you have to do some algebraic operation. Simplify the expression in front of the limit. Simplify this. Cancel something usually from numerator and denominator. Then substitution works. So at the beginning, if you try to substitute, never works in definition of derivative. If you remember from the techniques that we have learned in limits, when we have limits involving radicals, for finding these type of limits that we have radical minus something, look at the numerator, you have a radical minus something. For finding these type of limits, we do this. We multiply numerator and denominator by the conjugate of the expression. The conjugate of radical to x plus 1 minus 3 is radical to x plus 1 plus 3. And if you think you need to have more practice on these techniques of finding limits, watch my other videos about finding limits using conjugate identity. Let's back to this question. So for finding this limit, you have to multiply numerator and denominator by the conjugate of numerator. By doing this, when we multiply this by its conjugate, the radical cancels. Basically, if you remember this identity, a minus b times a plus b, it equals a2 minus b2. When we multiply something by its conjugate, this is conjugate of that. The reason we do this is that a raises to the power of 2 and b raises to the power of 2. And with this, the radical goes away. So, when we multiply the radical by its conjugate, the radical goes away. So what is the result of multiplying this by its conjugate? It would be 2x plus 1 minus 3 to the power of 2 or 9. Attention, when radical raises to the power of 2, the radical cancels. But because the 3 has no radical, when we raise it to the power of 2, it changes and it becomes 9. And in the denominator, we have only x minus 4 times by radical 2x plus 1 plus 3. Now, let's simplify numerator. If you look at the numerator, it is 2x minus 8. But before I write the denominator, attention to the 2x minus 8. 2x minus 8. Between 2x and 8, The 2 is the common factor. So if we factor the 2, we can write it as 2 times x minus 4. X minus 4 in denominator and radical 2x plus 1 plus 3 as x approaches 4. Now here, if you cancel the common term between numerator and denominator, we get 2 over radical 2x plus 1 plus 3 as x approaches 4. This cancellation that here happened almost always happens in the definition of derivative. During finding these limits, this should happen, that you simplify the numerators and this expression in the denominator cancels with similar term in numerator. Then substitution works. So you have to try to cancel the denominator with numerator. And as you can see, in this example, this happens. The x minus 4 with x minus 4 cancels. Now, if you try substitution, you can find the limit. If we plug in 4 for x, this would be 8 plus 1, 9. Radical 9 is 3. 3 plus 3 is 6. So this equals 2 over 6 or 1/3. So the slope of the tangent line is 1/3. Now that we have the slope of the tangent line, the slope of the tangent line is 1/3. And the point of the tangency, if you remember, was 4, 3. This was the point. Now simply we can write the equation of tangent line. The equation of the tangent line would be y minus 3 equals 1/3 times x minus 4. And it's up to you to multiply 1/3 in the bracket or leave the equation in this form. Let me show you how you can rewrite the equation in the slope intercept form. If we multiply 1/3 in the bracket, we have this, and if we move -3 to the right side, we have y equals 1/3 x minus 4/3 plus 3. Minus 4/3 plus 3 would be 5/3. Why? Because 3, if we want to do common denominator, is 9/3. And -4/3 plus 9/3 is 5/3. This is the equation of tangent line in another form. Both of these answers are the same, but it depends which form you prefer to write the equation of tangent line. Now let me show you how we can find the slope of tangent line using the other formula. What was the other formula? Try to memorize these formulas. Not to really memorize, by using these formulas for different questions, gradually you memorize them automatically. F prime of a equals limit of f of a plus h minus f of a over h as h approaches 0. This was the formula. What was the function? The function was radical 2x plus 1. What was the a? A was 4. So let us start finding f prime of 4. It would be limit of f of 4 plus h minus f of 4 all over h as h approaches 0. F prime of 4 would be limit h in denominator, h approaches 0. The common mistake between the students is in finding this part, f of 4 plus h. Attention, f of x is radical 2x plus 1. if this x changes, also you have to change here. If x becomes z, you have to make here z. If x becomes a, you have to replace x with a. Now we want f of 4 plus h. So replace the x here with 4 plus h. So what is f of 4 plus h? It equals radical 2 times 4 plus h plus 1 minus f of 4. Plug in 4 here. 2 times 4 is 8. 8 plus 1 is 9. Radical 9 is 3. So it's only 3. Now we have to find this limit. It depends to you to multiply 2 in the bracket or keep the radical in this form. I recommend you to multiply the 2 inside the bracket, then try to find this limit by doing the conjugate. So basically, before we start, let me tell you what happens if we multiply 2 inside the bracket. If we multiply the 2 by 4 plus h, we get limit h approaches 0, radical 2 times 4 is 8 plus 2h plus 1. 8 plus 1 is 9. So we have radical 9 plus 2h minus 3 all over h. And it's clear that for finding this limit, we have to multiply the numerator and denominator by the conjugate of the radical. Conjugate of the numerator. Radical 9 plus 2h plus 3 over radical 9 plus 2h plus 3. If we multiply numerator by numerator, 9 plus 2h, the radical cancels, and 3 raises to the 2, we get 9. All over h times radical 9 plus 2h plus 3. Look at the numerator. 9 minus 9 is 0, so only 2h remains. Let me rewrite this in another step so everything is clear for you. So after we cancel 9 with 9, we have 2h over h times radical 9 plus 2h plus 3 as h approaches 0. It should be obvious that h from the top with h from the bottom cancels, and then we have limit of 2 over radical 9 plus 2h plus 3 as h approaches 0. Now that h is cancelled from the top and the bottom, we can find the limit by direct substitution. If you plug in 0 for h, inside the radical would be radical 9, 3 plus 3 is 6, 2 over 6 is 1/3. And as you can see, the slope of tangent line is the same number that we got here. So it's completely up to you which method you prefer to use between these two formulas that here we had. You can use this formula or the other formula for finding the slope of tangent line. But usually we use this formula for finding the equation, the slope of tangent line. I hope by watching this video you have learned how to find the slope of tangent line using definition of derivative. If you want to learn more about this topic, watch the next part of this video. In the next videos, I'm going to show you more examples, and those examples are a bit, of course, more complicated, so you can learn better how you can use definition of derivative to find the slope of tangent line.